we are live from downtown Mill Excellent. Okay, you drew some Bohr models. I took an average and put it up there. Couple of points. All of you that are putting them really far apart, they should actually be, please put away your book. Those are as bad as iPhones. They're too tempting. Away, 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 away in your bag. I sympathize. I read all the way through math class to the point that my English teacher told me I read too much. And if you can imagine how much it takes for your English teacher to say that you read too much, that's what I did. When you make a Bohr model like this, you will be in better stead. How many electrons fit in the first shell? Two. So put them together. They pair. Only two fit. So if you're at the maximum, they have to fit. And if you were to do the second one, how many fit? 8. So you'd actually go like 1. And this is like, did I mention the bathroom stall analogy last day? So next one would go really far away from him, or them, or her, and then really far away. But once you fill up the 4 corners, now they have to pair. So then if you had to do more, they start pairing. How many fit in each shell? First shell is 2. Next shell is 8. Next shell is, yeah, next shell is 2. Pull your periodic table. Turn to this page. I still don't have my periodic table up, so. 18. How do you know that?
18 groups.
Oh, 18, yeah, 18 groups. So how many elements are in the first row? Someone else. No, you count across. How many in the first row?
3.
No. Oh, I know what you're doing. They put hydrogen twice. Your other periodic table doesn't do that. And that's an interesting thing. They put hydrogen twice because some periodic tables put it here, and some periodic tables put it there. And that's because hydrogen can be both +1 and -1. And this one gets around that problem by putting it in both places so that you can miscount it, I presume. So 2, and how many in the next row? 8. And next row? 8. And then 18. So if you count across, there's 1, 2, and then there's that block in the middle. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you get 2, 8, 8, 18. And it's kind of interesting. This was designed by Mendeleev in Russia. And he came up with this before they knew about protons or neutrons or electrons. He didn't know anything about that. He didn't know about energy levels. But because it's a periodic table, why is it called a periodic table? No, you've already answered one. Yes?
Periods?
These are called periods. Why are they called periods? Julie? You answered the question and immediately you went like this, but it's called periodic because of that's a bit like saying like, we're teaching, so why is a teacher called a teacher? But what is the root? Why is it called a period? Same numbers of letters? I think I know what you might mean, but I'm not sure. What do you mean by same numbers of letters?
Layers.
Layers. They do have the right. Oh! Are you talking about electron layers?
Yeah.
SPD?
SPD. What is SPD?
Oh, okay. Just got beyond what you knew. You're right, there are layers there. They're talking about electron layers. And he didn't know that, but he called it the periodic table before they knew about electron layers. So how did he get this structure that perfectly fits the properties of atoms before you could even know about that? What is the, maybe get away from the periodic table where you see the word periodic in that context. What just does the word periodic mean, or period? Yeah.
Like it's in a cycle?
It's in a cycle. Something repeats. I mean, the most famous one, of course, being the menstrual cycle, to the point we use the word just to mean that, because it occurs to about roughly half the planet's population. But If we look at this, take lithium, you throw it in water, it explodes. You take the one beside lithium, you throw it in water, and it will react, but it won't explode. And this first one, lithium is +1, that's +2. We just go with simple properties as we go across. We got +3, ±4, -3, -2, -1, a noble gas. And then if we went to the next element, it's +1, and it explodes in water. We're back at the beginning. And so the properties repeat. And if you just sort them out by properties and mass, you create the underlying electronic structure of the, before they even knew. And so you can use this to figure out how many layers are in. It's also somewhat of a lie, because you will see printed in textbooks that will not explain it to you. I think it's in your textbook actually, where it doesn't say 288. If you look it up, does anybody know what that number actually is? It actually is 2882. But if you use 288, you'll get the right answer. And at a deep level, here's what's going on. That 2 is in fact 2. For every electron level, you can fit in 2 electrons. So I'm just going to put a line in for each electron. This is not 8. It's a 2, 6. So I would go, and this would be 2, and this would be 6. They're also, if you notice, at a slightly different level. I'll exaggerate it for effect. But they're close enough. We call this the first. We call all of these, they're in the second. They're slightly different. We give them letters. So when you were saying layers, this is the S layer and that's the P layer. This is the first S layer, that's the second S layer. This is the second P layer. But it's first, second, you don't have to worry about the letters. And then the next one is the third layer. You still get the 2. So you get 1, 2. And then you get this one there. And you get a 2, you get 6. That's the same third layer. But the reason that we say 18 in that layer is that there is another one. Now another one pops up that has 5. 1, 2, 3, 4. How many electrons will fit in 5? 10. Because you get one, they all pair up. When electrons are forced to, they like to be in pairs. You won't see triplets or anything. So you get that 10 layer, and 10 plus 6 and 2 is 18. That is first layer, second layer. That is in the third layer. But now we start the fourth layer, and the fourth layer starts like this, and then you get the fourth P layer, so you get 6 electrons there. Can you notice anything about the spacing of those lines?
They're getting wider.
They did get wider, and I did exaggerate some, but they actually really do in some ways, yeah?
The third, the D layer.
Oh yeah, this is actually, I said this is S, that's P, this is the D layer.
The D layer looks closer to the fourth layer than.
Yeah, if we were to put it here, the D layer fills up after the fourth layer starts. So it fills up this layer, it hops over to the third layer's D section, and then you fill up the fourth. And so that's why you get 2, you get a 2, 6, and then you get a 2, 6, 10, but it doesn't fill up. And then the next layer eventually goes 2, 6, and its 10 doesn't fill up, and it all moves over 1. The weird thing is once it's full up, it actually relaxes, and it comes back to join its buddies, and it will unfill in a different way. It'll unfill in a different order. So there is a deeper complexity going on than just 288. And now is where I get to tell you that you're not allowed to know any of that. And we're not going to do that. We're just going to stick with 288. But if you go on to Chem 11, that's quantum chemistry. Quantum chemistry is not that hard. You're just putting things in energy levels.
We need to know that 18, 2 layers, and the 32.
No, the only thing you need to know, I have a summary sheet that'll say, like, this is everything you should know from grade 9, 288. That's it.
No way to
No, I'll never take, the next layer I would just assume you could go up to at least, and now that you know how to count, you probably could do it, but actually we don't go beyond 2882. We only go up to calcium, the first 20 elements. Yeah, I know. It's grade 10, province of British Columbia. I mean, I tell you about it, but then I go back to here and say, you see these lithiums? When you draw these, it makes me sad because I have to count. I don't want to count. It takes too long. And I may ask you to draw like 20 Bohr models. If I do that, this is not a better way, but it's a more efficient way. You can just say, oh, lithium, 3 protons, if I've asked you to include the protons, otherwise you could write lithium. And then you could go, and first there was 2 electrons, and then 1 electron. And you're done. If I asked you to include the neutrons, you could go 4 neutrons, and you're done. And then sometimes we do this just to show that they used to be orbitals. So I asked someone once, I drew those on, and someone said, why do you draw giant 1s on either side? I'm not drawing giant 1s. That's just to indicate the circles here that used to exist, and to reference the fact that these are going around on levels, and they go around the entire atom actually as a sphere, not just as a circle. But we don't want to draw them all, so we will just do that. And that, you'll see that. It's very common. If you want to be extremely compact, you can just go 3 protons, 2, 1. If you've written in the protons, those obviously must be electrons, and you can just omit the E. If you really had to include the neutrons, you're allowed to put it in. But you can draw it extremely compact as well, because you might be drawing a lot of those. So you had this, I'm assuming a lot of you in grade 9. If you're going to be drawing more than a lot of them, you're allowed to do this. In fact, many times I would prefer if you did that. Good? Pardon?
Easier for you to mark.
Easier for me to mark. Absolutely. And that is the only criteria, of course, that I care about. Any question? Anybody need another minute on that? And if I'm standing in your way and you can't see a lot, tell me to move to the other side. I don't mind. I mean, this whole thing is sort of jury-rigged together. Fill in the table. And then,
What do you want for mass?
oh, put the mass in AMUs.
Do we know the mass?
Yes. In AMUs only, though. Not in grams. That would be too small of a number. If you don't know, you can leave it blank and hope I ask someone else. You can consult with others. I am going to warn you, I'm going to try and use my app today. What I do is I press a button, and it tells me, Hillary Stone. Hillary Stone? Excellent. You'll be answering the first question. Okay. It randomly picks someone, and then I give them points. Currently, Hillary's winning. She is 1 point ahead of the rest of the entire class. What I'm going to do is I'm going to call on you, and then I'm going to ask you to give me all of them for a column. And then you will have a choice over which column, because you're going first. So pre-warning, fill it in. I'll give you another minute. The purpose of it, just while you're filling in, is so that if I just ask questions, did I talk about bias last day?
Bias?
Bias. Teacher bias? Okay. If you want the highest grade in a class and you don't know anything about the teacher, where do you sit? In the front where?
Right next to you.
Pardon? Not in the middle, actually. There. Why there?
That's where you are.
Yeah, but why not there? Like right here. If I turn the desk around, why?
Because then you'll see them more often.
Why will I see him more often?
Because you desks are there.
Oh, yeah, in terms of physical layout. But any teacher, even if you didn't know the layout at all, you just knew it was desks in a row, right there is always the best spot. Yes?
You're the first person, like, if they look like at the whole class, it's the first person.
Yeah, but why? If this row kept going, why wouldn't I look there first? Why isn't there? That's almost as good.
Because out of your way.
Could. It is out of my way in a sense because I have a very distinct uniqueness. Everybody has this distinct, it's not that unique, but I am right-handed. So where does my attention bias go? To the right. I tend to ignore things on my left. That's just a thing everybody has. If you knew I was left-handed, where should you sit? There. But since I'm right-handed, that's the worst spot to sit in the entire world. But I have an app that will randomly ask you a question and it doesn't care where you sit. So it offsets. What if I just, happen to only ask people from a certain house a question? Or if you happen to have, the three people who aren't wearing blazers and I just notice you more and you get more questions, then everybody else loses out. This way I can be efficient. And let's say your parents took you to Hawaii for 2 weeks in the middle of the school year, your points will drop. And then when you come back, I could say, oh, you're 10 points behind in questions. You get the next 10 ones that catch you up. More-ha. More-ha. You're right there. A automatically. Notice also how I try to stand. I'm here, so everybody's somewhere, right? Done? Oh, with my glasses off, it looked blank. Okay, anybody still need another minute?
I mean, I just don't get it.
Oh, okay, that's fine. Oh, another important rule. If I'm asking you questions, in many cases, I haven't told you the information. You're allowed to consult with other people. You may not understand it at all. The fact you don't understand is actually useful because then I can bounce off of you to create the information for everybody else who doesn't understand. However, Julian, there's an important part of that process. If someone doesn't understand, number one, don't offer the answer to me in place. It's not a race. You're not trying to present the answer to me. You can help them if you'd like, and they can get the answer and work together. Also, support them in doing so. We would never make fun of someone for not knowing the answer. We would never call them out for not knowing the answer. You just might not know the answer. Most of the time, I didn't know the answer, and I learned because I made a mistake. Also, you should know you're being taught chemistry by someone who passed Chemistry 12 with 51%. Guess what my degree is in?
Chemistry?
Chemistry. Yeah.
What do you pass your university degree?
I actually have a chemistry, biochemistry double major, so sometimes I also teach biology. Junior physics at this level. I took honors physics at university as well, but I didn't get a major in it. But I ended up doing a double major, which is the most difficult bachelor's degree you can get because biochemistry and chemistry are both considered the two of the hardest areas. And I got 51% in chemistry 12 because I didn't do my homework. Ever. And then when I was in university, and I loved physics. I had like 98% in physics. And I was taking first year honors physics. And this is not intended to stop you from taking physics. This is just at the time. First, the class was entirely one gender. And I was nerdy in high school. I liked read science fiction, fantasy. I liked D&D. I saw some of the first, animes being smuggled over. And these people were too nerdy for me because they were so nerdy they didn't bathe. And the class would just smell. So I dropped physics and took computer science. And that was a crushing mistake because it turns out those were the same type of people. It didn't change. And then I thought long and hard, and I thought, I like science. What can I go into where the people are more normal? And then I thought, well, I liked chemistry. I just never worked at it. So why don't I try chemistry? I took chemistry university. So if you're like, oh, my teacher only 51%, I have a whole degree in it, and I did well. And I added on biochemistry because then I found the biology people. They smell nice. They know tons about bathing, and they go outdoors and have walks. Biology people are great, so I eventually also got the biochemistry, and I like growing bacteria and stuff. So don't worry. Also, if you don't know what you want to do, I didn't know what I wanted to do until I was my third year university after changing my major 1, 2, 3 times, and then tacking on another one. Okay, go. Which column you want to do?
Are you talking about downwards?
Yeah.
I'll do the symbol.
Symbol for electron.
Electron E, P, N.
Excellent. All good. The only thing I'd add for an electron, you must include the sign, and that's because math people are irritating. Protons you can or not. I always do because I otherwise get confused. And neutrons you can or not. Does anybody know why you have to include the negative sign for electrons only? Yeah?
That's the charge level?
It is the charge, but protons you don't have to include it, although we know it's charged.
What's the app called?
What app?
What are you using?
Oh, it's made for kindergartners. It's called Class Dojo.
Yeah.
Yeah, yeah. It's like you were good in class and you shared, and I can give you points. I just use it for tracking like other random things. Has anybody heard of the number E in math? E is a number in math in the same way that pi is a number in math. So they don't want to confuse the E's, so that's why they ask that you put on the chart.
Something like 2.8 something.
You would think so, but mathematicians are a little slow. Sorry?
Something like 2.8 or something.
Yeah, yes it is. I don't know exactly what it is, but it's around there.
Why is it that? What is these?
Because
Uh,
it's annoying.
No, it is a, I can't remember what the number represents, but it's a specific thing, just like pi is a specific thing. If you go into astronomy, pi is equal to 10. If you're in chemistry, pi is equal to 3. If you're a mathematician, you talk nonsense about decimals repeating forever.
Why is it 10?
Because when you're an astronomer, you're dealing with numbers like a 10 to the 20, millions of light years. If you're just doing calculations at that level, 3 and 10 is the same number. Okay, next one. Oliver, pick one.
Charge.
Charge, what are they?
-1, +1, 0.
Excellent. So they're +1, -1, +1, and 0 is their charge. Vienna,
Location.
location.
The clouds.
Cloud. Excellent.
The center.
What's the center called? There's a chemistry term for it. It's also the very center of a cell. Nucleus. Right root.
And then
Also
also
the nucleus. In Latin, the word nucleus just means center, which is why we use it in both biology and chemistry, and they mean different things in each one. Julian GG, you're left with mass. Yeah.
It's 0, 1, and another 1.
Yeah. Yeah. Well done. So the atomic mass unit is defined, well, I won't say what it's really defined as. That would be too confusing. Because then I'm going to get into quantum again. But we just define a proton weighs 1 AMU, a neutron weighs 1 AMU. So if you wanted to add up how much something weighs, on your periodic table, how much does oxygen weigh? I'll give you a question in a moment. Take your periodic table. What does oxygen weigh? How many AMUs? 16. So if I had H2O, what would that weigh as a total? No, your hand was too fast. I'm going to wait until more people are up there. I'll take the fourth one. Pardon? Too fast. No. One oxygen 16. No, don't give up. If one oxygen is 16,
And then 2 hydrogens is 18.
18. Excellent. See? So one oxygen equals 18. This allows us to use our periodic table because you can just count protons and neutrons very quickly and get their atomic mass unit. And this down here is a magic number that I'll introduce more next year in Chemistry 11. If I have 1 AMU is equal to 1 over 6.
Are you having fun there?
Yes, because it's my favorite number. 1 AMU divided by that is how many grams, I'm not going to do it, 1 AMU is. You can convert it,
Why do you want to convert it?
because now we can do a magic thing. It's literally like magic. Because you can't go, if I said go to the lab and bring me 7 carbon atoms, that would be, you need a really, really small pair of tweezers and incredibly good eyesight. But If I said, bring me just a precise amount of atoms, I just want you to tell me the number of atoms, but it needs to be a precise amount. Well, then you could go to, you know that H2O is equal to 18 AMUs. And you know that, and I'm going to convert it, and you've done scientific notation in grade 9. We'll redo it later, but you've done it before. 6.022 times 10 to the 23rd AMUs is equal to 1 gram. Okay? Now I could go up to the lab, and I can weigh out 18 grams of H2O, and I know at that point that I have 6.022 times 10 to the 23rd molecules of it. I know I have 6.022 times 10 to the 23rd atoms of oxygen, because there's only one there, and I would know that I have 1.2 roughly times 10 to the 24, or 12 times 10 to the 23, because I just have 2 hydrogens, so I doubled it, atoms of hydrogen. So now I can, with an ordinary kitchen scale, count atoms. And that was a fantastic number to find. Because once we can count atoms, we can now measure anything we want about reactions. It was hugely beneficial.
I don't think your kitchen measure can accurately do a gram to the atom.
My kitchen scale can measure to the nearest 0.1 of a gram. I've got one right here, actually.
Not to an atom though.
Oh, well, not to the, but do I care plus or minus an atom? If I'm doing a reaction on the bench, and I know that I have 6.02 times 10 to the 23rd molecules, who cares if 10 or 12 molecules fall off? I can measure it to 3 decimal places. Or however I go. If I measure 18.0 grams, then I know the number of molecules to 1 decimal place. That's pretty good. When we measure with a ruler, we only know to millimeters, and that's only 1 decimal place or so. You can get maybe to 2 decimal places. And in the lab, if you want more decimal places, you just get a better scale. We have a scale in there. It's not working anymore. But it's similar to one I used to use in university. It's a microgram scale. It can measure to that many decimal places. So we don't have to count to the individual atom. We just need to count to the nearest million atoms, 100,000 atoms. But we still know the ratio. We know that this is half of that. And now we can start, 2 to 1, that makes sense. And if we want to make water, then we know we need to get 2 grams of hydrogen and 16 grams of oxygen, and we have the right amount. Plus or minus 100 million atoms or so. Does that make sense? Yeah. And that's all chemistry 11. You can ignore that now. We put all that in. Ooh, no, we skipped over that. What I would like you to do instead.
Sodium. That is a real thing.
Yeah, skip over that for a moment. Go to this page. Just gonna finish that out. Write down what all those things are. I'll ask someone again.
That's not a real atom.
Snowium is not a real atom, and it would be a little much if I put Neufeld out there, but this is my opportunity to say, it is a long-standing in chemistry, going back hundreds of years, that if you discover an element, you name it after your grade 10 chemistry teacher.
Yeah.
So if you ever discover an element, I expect a Neufeldium to be out there somewhere, so that I can tell Mr. Snow that the only snowium that exists is fictional and in my classroom. Always remember your grade 10 science teacher to help you out. If you make any scientific discoveries, there will be people out there that will take advantage of you and try and cheat you. Just bring your discovery to me, and I'll make sure I'll take care of you and give you what you deserve. Hold on. Excellent.
I'll give you that. I'm never going back to this class again.
Yeah. Okay, this hopefully shouldn't take too long, so I'm going to start off with the first one. Zachary. Where's Zachary? Are you Zachary? Okay, go. What's the top one?
The number of protons.
Yes.
And the atomic
What's that?
number.
Atomic number. So atomic number. Just to orient ourselves on our periodic table, atomic number. The pen's not working right. I think the computer's slow. So that is the number of protons. It's identical.
I can't read your writing. Can you like?
Okay, what does it say?
Oh, yeah, there's no way.
Oh, beautiful.
Ain't no way.
Beautiful.
Ain't no way.
A computer with zero intelligence. Read my writing. Not to imply anything, just saying it.
Sure.
Just saying. Yeah. Okay.
It's actually quite cool.
Lucas, second one. Where's Lucas?
I don't know.
Oh. First of all, do you have your periodic table out?
No.
No. Because the secret part is that they're here too. So what's the second one? What's that? Look at the very top of your periodic table. There's a key.
Oh,
It's a symbol.
I'm kidding.
And
The abbreviation.
it is you could say abbreviation. And I want to take the moment to just to mention something important because, like, obviously it's the symbol. What are you talking about? What do you notice about with the way every single symbol is written on there, Julian? The first one is capital or uppercase, and the second one is lowercase. Yes?
Some of the elements don't have.
Some of them, yeah, don't have two. There are a few that have three. And the thing I want to mention is because grade 10, you've done science 9, but some of you have come in with some writing habits that will get you in trouble in chemistry. And that is, some people like to write in all caps. They just write everything in capital letter. And that means that cobalt you can't tell the difference between cobalt, which is a metal and it's very useful. It's mildly poisonous, don't eat it, but you can be in the same room as it, with carbon monoxide, which you cannot be in the same room as. I'm not going to discuss carbon monoxide because I made a story yesterday that really made the other class sad.
Oh, let's hear it.
No, it was too sad.
Do tell.
No. No, like,
Oh, wait, so
okay,
go
I will
back
tell
to
you
the
one
live
fa-
stream from yesterday. Go back to the live stream.
no, because the live stream from yesterday didn't work.
Bruh.
Yeah.
Sure.
Yes.
They just like kill people with like,
Okay, I'll tell you one fact about it. An entire family died except for a 5-year-old girl.
Okay. let's
Okay,
hear it.
please do tell.
Never cook anything that belongs outdoors, like your barbecue or any outside heater that says an outdoor heater. Never bring it indoors. And the reason you don't bring it indoors is because combustion, which is any kind of organic compound, whether it's wood or propane gas, it doesn't matter. It'll be some sort of carbon, hydrogen, maybe other stuff compound, plus oxygen gas. This is a combustion reaction. We'll memorize it later. Gives off water and CO2. CO2 is carbon dioxide. You wouldn't want a room full of carbon dioxide, but it's not a direct poison. You breathe it out all the time. However, under low oxygen conditions, which in a fire happens all the time, it actually also gives off carbon monoxide. Carbon monoxide, what carries oxygen around in your blood?
Your blood.
Yeah, what part of your blood?
Hemoglobin.
Hemoglobin. And what cell is the hemoglobin in? Red blood cells. The reason blood is red is for the same reason that iron is red. Hemoglobin contains iron, and when it binds with oxygen, it gets even redder. So oxygen goes onto the hemoglobin, goes to your tissues, and it comes off. Goes back to your lungs, binds to an oxygen, goes to your tissues, comes off. Comes here, carbon monoxide goes on, goes to your tissues, doesn't come off. Carbon monoxide fits hemoglobin too well, and it sticks to it, and you can't get it off. And so now you have this red blood cell not carrying oxygen. If all your red blood cells are filled with carbon monoxide, even if you get to fresh air, you cannot breathe. Like, you can breathe, but there is no oxygen binding. You're not getting oxygen to your tissues. So this family in Ontario wanted a barbecue. It was really cold outside, so they pulled the barbecue inside. They cooked their burgers and steaks, and then they felt sick after the meal, and then they went to bed. And the girl lived on the top floor. That's where her bedroom was. So the carbon monoxide, she didn't get enough because carbon monoxide is heavy and was on the bottom floors. So she woke up, and none of her family was alive. That's not a good story. Thank you for applauding for telling it. But so safety, chemistry, don't do things with things in the wrong place. Don't stick. I found out at least 3 people in class didn't know you're not supposed to stick a fork in a toaster that's plugged in. You can actually cross the lines and get electrocuted that way. I caught a 14-year-old boy. I'm going to leave him unnamed doing that. I'm like, what are you doing? He's like, I always do this. I'm like, yeah, but it only takes one. And then I explained, and he genuinely never knew.
Was it Lauren Evans?
What? I'm not going to say who it was.
Last year.
Yeah, I'm not going to say who it was. So there are safety things. By the way, if it makes it any better, that little girl did grow up, and she's now a teacher in Toronto, I think. So her life turned out fine. If that's like, oh, it's better. That doesn't make it too much better. Maybe a little better. So what an element is important. This has to be uppercase. That has to be lowercase if there's 2. And you can't do this. So for example, I'm going to make up one. Let's say you had this type of, actually a real one, germanium. So that says germanium. I don't know what that is. You have a giant lowercase g. So that could be geranium, that could be nothing. It must be uppercase and lowercase. Do you know where the words uppercase and lowercase come from?
One's upper, one's lower.
Literally, kind of, yeah. The old printing press where you actually took metal pieces of letters and stuck them in a row, and then you would go chunk, chunk to print paper, like a newspaper. So when they were grabbing the letters, most of the letters are the small form. And since they're the ones you're grabbing most often to put in the printing press to make it, they were lower down so they were easier to reach. And then when you needed the larger letters, they put them on the upper case, and then they would grab those whenever they started a sentence, because you only grab those once in a while. And that's literally where uppercase and lowercase comes from. It's from physically moving things on a printing press. We still use the terminology even though we don't use the machines. I mean, our whole world's full of that. I mean, the size of rockets is determined by the width of a mule's ass. So
What?
Wait, what?
when we looked at the length to make train tracks, they were based on 2 mules walking a wagon cart and how wide that had to be. And they had to fit on existing areas where they already had tracks. They'd already built tunnels for sometimes these caravans with 2 mules. So they made the tracks to fit the tunnels that were made to fit 2 mules. Then when they built rockets, they had to put them on trains, the parts of which had to fit through the tunnels that were made for the width of 2 mules. And so they literally made parts, and they would have to, at NASA, design them to be smaller and then interlock later because they had to fit through these old things. We build things, but and even after they're gone, their history continues because it's our foundation. So all train tracks are based on mules, and the mules themselves are based on old trail tracks from the original, trails that were there before that.
So rockets are basically mule.
Yeah, one fundamental level, yeah. Okay, I've done a side talk way too much, so I'm gonna just go on. This is the name. Pardon? And this one. I want to know this one. What's that one? Hand. Atomic mass.
Sorry, too much effort.
Does anybody know what the atomic mass represents? The back.
Isn't it the mass of the neutrons and protons together also? Even though electrons, their mass is like so small.
We ignore them because they are so small. It is not the protons and neutrons added together, but it also is in a very special way.
Oh, wait.
It is the average
Oh, because of isotopes.
number of protons plus the number of neutrons. Did I do the family example last day for averages?
Oh, yeah.
Yeah. So same as that. That's an average. Does anybody know what the one that isn't an average that actually applies to, like if I give it to you? Yes? No, that's an element. Does anybody know what protons plus neutrons, if you just have that as a number, not an average, the number for an exact atom, it has also a separate term. Does anybody know what that is? Pardon?
Isotope.
Isotopes have them.
Number.
We'll get to it. That's fine. Neutral atoms have what kind of charge?
Zero.
Zero. So no overall charge. Just to summarize, what two subatomic particles equal each other if you're neutral? No, you've answered a lot. Oh, hold it. What am I doing? I have my app. I'm so pleased with myself.
Can we join the class dojo? Can we get a prize? Can we join the class dojo?
No. Well, I mean, technically, I give you codes.
Yes, can we please?
I will see if I can set that up. Julian, Chan,
Question?
what two subatomic particles have to be equal?
Proton and electron.
Excellent. Which one's negative?
Electron.
Okay. Electron and proton. The atomic number. I'm going to set up the next one. Oh, no, that's the summary page. Oh, we're doing it right away. Excellent. What kind of number does the atomic number have to be? We already know that it's the number of what? Mirhat. Pardon? Protons, yeah. So it's the number of protons. But what flavor of number does it have to be? I'll phrase it another way. What number can't it be?
Decimal.
Pardon? Negative? Can't be negative.
A decimal.
Yeah?
Can't be any other number than what we
Oh, no, I'm saying considering all atoms, there's certain numbers it could never be. Continue, yeah?
decimal.
Can't be a decimal. So what kind of numbers can't be negative, can't be decimal? What do they call the math class? What kind of sets? Integers. Well, it does, don't integers include negatives?
Natural numbers.
Natural numbers.
Zero.
A natural number.
Can't an atom.
Or we could say whole number, I guess.
Whole number includes zero.
Does it?
Yeah.
I'm going to ignore that. It's the naive theory of chemistry. All atoms of the same element have the same atomic number. So the number I was looking for before was the mass number. The mass number has to be whole number or natural number that counts the number of protons plus the number of neutrons in the nucleus. So it has to be a whole number. You can't have 6.9, just like you can't have 2.3 siblings in a family. So the mass number is the protons plus the neutrons. Yes?
You sure you can't rewrite it as natural?
Do natural not include zero?
Natural is just 1, 2, 3, 4.
Yeah, it should be natural number. I'm easy though. I mean, theoretically, you could include zero and just say that's the one that's not anything. There is actually an element that has zero.
Really?
Yeah.
How does that work?
Well, it has 0 protons.
And 0 neutrons.
No.
That's the mass number.
No, they made a stable element. They called it an element, but it was a stable grouping of neutrons only.
But those still have more,
The mass number, yes, but not the atomic number. Because its protons would be 0.
so also 0 electrons.
Yeah.
What is the point?
Technically, There are certain types of stellar bodies that are just one giant atom and all they contain is neutrons. It's a neutron star.
Seriously?
Yeah,
What kind of stellar body?
neutron star. Yeah, you can think of them as giant, really weird atoms.
That sounds really cool.
Now, this isn't on the periodic table. We're going to learn to write it in some particular way. Do we do that next? I think. Nah, we do that after this. What I would like you to do now is take out your periodic table. Take out this one, the one that looks like this, and a pencil. So not the colorful one, the one that looks like this. Yes. Then I want you to think really hard at it when I tell you what to do next. You just have to remember it. I promise not to cheat.
Mr. Newfield, do we need to write anything on it?
You'll need a pencil. 1, 2,
No.
1, 2, 3, 4, 5, 6, 7, 8. Well, someone's moving. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15. So there will be one trio. Yes? No. Because I want you to be able to erase it. If you have an erasable pen, other than that, again, if you don't have a pencil at all and you can't borrow one from someone, then just stare at it really hard. I want you to pick an element between 1 and 26 and circle it in pencil if you can. With a partner. Find a partner. There needs to be one trio. There. There. You're gonna go over there. Okay, go. Pick your element. There. 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 Excellent. Pick your element. Oh, wait a minute. They have a new function in Class Dojo.
Root maker.
Yeah, I'll do it next time. I'll do it next.
You know, you're like a year behind my LA teacher from last year, right?
Probably. I mean, I only use it for counting random people in class. Okay, does everybody pick their element? Yeah? Good. Go to the board, erase anything that's on there, and I want you to draw it. Draw the Bohr model. Label what element it is at the top. If there is writing already there, just erase it. Oh, yeah, perfect. Erase things.
Which one should we do?
There should be cloth. You're using the world's smallest eraser, but I guess it's fine. Any more eraser? If I can reach, oops, sorry, reach first. I just realized these aren't put out. Wait, more pens are up here if you need them. Once you've drawn it, sit down. No, but right, what element is it? You're very like, evaluate me. My name is there. This is very formative.
That's not how you draw now.
Yep. Who said no?
Continue to sit with our groups.
No, you need to sit down where you were before. That's fine. Because now I realize I can give you different groups. I don't know if we'll have. What time is class at?
Can we choose your own groups?
What's the calendar say? I always forget what it does. 11:45. Oh, we gotta move. I'm not gonna tell you. I'm just gonna have you sit down.
So you did earlier.
And then I'm gonna comment on it. Go. Go. Yeah. I don't know. I have to go through that. I think I have to print out a code or something. Most of them aren't even hatched yet. You're just new eggs. What would you play?
No, play it. We used it.
Oh, you used it. Okay. Nice. Okay. Let's go through your Bohr models. Oh, nice. Someone picked helium. That's easy to check. 2 protons, 2 electrons. That's good. They've written it very tiny so none of you can see. 10, 11. That's good. That's good. Perfect. I'm going to deal with you later. 8 and 8 is 16. 16 plus 4 is 20. 20 plus 2 is 22. Protons and electrons match. That's good. I'm going to deal with you later. 8, 9, 10, 11. Sodium. The protons and electrons match. That's good. Deal with you later. 7 is 14, 15, 16, 17. Matches the number of protons. That's good. So, imagine I'm marking. You've given me a bunch of Bohr models. There's good music on. I've got my purple pen because I like to mark in a festive color. I've got a nice cup of coffee or something, and I'm relaxed, and I'm just like, boom, boom. Now I have to count. Now it is technically a correct Bohr model. I can't really criticize you on that. All I'm going to do is shut off the music, get out the red angry pen, put away my cup of coffee, get out my good glasses, and really go to town. Because now I have to 2, 4, 6, 8, 10. 11,
They missed the
You
two.
missed
They
the
missed
number.
two.
12, 13. Yeah, and I'm like, okay, I guess you're right. You know, that circle's not quite enclosed. There's a gap. Why is that? Much meaner, much more critical, but technically correct. Okay, 22 protons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 19, 20, 21. Is that one?
Yeah.
No.
Oh.
Overlaps.
What?
-1.
How does that overlap?
What if that circle's actually part of the 2? I can't tell the difference.
Then you're sad.
It's really sad, yeah.
Mine
2, 4, 6, 8, 10. I don't know, this part here?
What?
It's not a circle.
This is gonna be a mess.
No
The
bugs.
electrons might not be perfect circles.
Yeah, I should probably take off more marks. Yeah.
Well, and then
Humorous point aside, start using the new method because it makes it faster, but also it's just faster for you to write. And if you want those kind, also we'll be doing some of that because there is a time and a place where you do that. We're going to do Lewis dot diagrams, where the Lewis dot diagram is super easy. You just take all this stuff in the middle and you throw it away, and you just go aluminum. In this case, you would go 1, 2, 3, and then you're done. And then you go this one. Oh, what element is 11? Is that sodium?
Yeah.
So you just go Na. There's 1. You just go 1.
valence electron.
And it starts looking valence electrons. Excellent. And then you start doing it with all of them. So the skill's still useful. We just, when you don't need it, don't use it.
What do you mean aluminum 1, 2, 3, or
The valence electrons.
So
The outermost.
on the outside, this person put them paired, but you don't actually pair them if you're doing this until you fill up all 4 spots, and then you start pairing them.
Sorry, you left all of most of your electrons with gaps in them.
Pardon?
Most of your electrons have gaps in them.
Yes,
Like
yes they do.
subtract 20
Yeah,
points.
oh, I gotta remind it some more. But otherwise, very good. There is a page which is a review of all the things that are roughly grade 9 chemistry Bohr model. So if you forget things like 288, but now you know how to get it off your periodic table. We don't actually ever really go to 18. Technically speaking, in the province of British Columbia, where the most we go is like 2882, up to calcium, 20 elements. But you would be able to do it. It wouldn't be a problem. That was our drawing on the board. We already did that. Oh, excellent. So, oh, this is the chance. This is the chance we've been waiting for. Custodial. And toolkit. Oh, group maker. Julian, you have dealer's choice. You can join any group you like.
Join us, Julian.
Find your partner and answer this question. I want you to draw atom X and Y and tell me how they're the same and different. Find your people.
I'm here.
What exactly?
Mr. Newfo,
I'll put the question back up once you have your partner. Find your partner, get up there and
do I
erase.
need a pen or a pencil or anything?
No, you're drawing on the whiteboard.
Alright.
Grab your partner, go to the whiteboard.
Why am I not a monster? Why am I not?
There's so many eggs.
Mr. Newfeld, can you make me a monster? I don't want to be an egg.
You eventually hatch, actually.
What?
Everybody will become monsters.
Whoa. Hatch. Something.
You actually hatch based on the number of points you get.
What? Can you give me a point so I can match this?
I'm going to have to. Well, you'll get one when I answer the question.
Can I swap my monster? I don't like it.
No, stop it. Okay, does everybody have their partner?
Liam.
Yeah, I'm
You
coming.
don't need your periodic table to make atoms.
Okay, no, they're not. They're real atoms.
Really?
Yeah.
But
Mr.
you said
Newfo,
they're
I'm joining
atoms.
and being.
Perfect. I have given you two atoms, atom X and atom Y. This one has 9 protons and 8 neutrons. This one has an atomic number of 9 and a mass number of 17. Draw them both and tell me what is the same and different between them.
Yes. And 9B carbon. Are these not the same? No. Oh. Wait, 17? Oh. No. 9. Wait, what?
Atom X is not equal to.
I swear they're the same. They're the same amount of protons.
That's the same.
Same amount of protons, but different.
Oh.
Oh. Oh, I misjudged the time.
I got it.
Okay, you may go because I
But
can't
there's
keep you
zero
any longer.
difference. They're the exact same.
The exact same.
The difference is
Oh, thank you for the answer.
No, you can't write on there. No, clever. Clever. 2 people can actually draw at the same time. I haven't checked 3 people. Let me do that. Oh, yeah. 3 people. Ooh.
4.
4.
Whatever works.
They must have improved this. There was at one point only 2 could. So it must have been updated. Oh, don't do that. Yeah, I don't want it to erase. That's really fantastic. I don't know. You can draw at the same time, but I don't know if you can control and draw.
Hold up. So. Wait, what happens? Hold
Oh,
on.
you're not on pen anymore. You're on writing.
Oh wait, let's make this. Let's make it bad. Wait, paste.
Oh.
Yeah.
Oh yeah, we don't necessarily want to display everybody. Yes, I should probably stop doing